Hello everyone, my name is Nikhil sir of Support Classes Hatturasti Hudgi Road, Shulapur. We have started 9th chapter of Science of class 9 NCERT, that is Force and Laws of Motion. In that we have studied some part of this chapter in our previous videos. Please students, those who are not seeing my previous videos, go through my previous videos. I have given link of those videos in my description box. You please check my description box and go through those videos. Now today we will move towards next point in this chapter, that is activity 9.1. Please student, put your textbook in front of you while watching this video and be ready with your pen, pencil and notebook. Make a pile of similar carom coin on a table as shown in figure 9.6. You have to make a pile of similar carom coins on the table. See here, in this way you have to put. Attempt a sharp horizontal hit at the bottom of the pile using another carom coin or the striker. You have to attempt a sharp horizontal hit at the bottom, means here, by using a striker. If the hit is strong enough, the bottom coin moves out quickly. When we hit strongly at the bottom coin, that time what will be happen? That coin moves out quickly. Once the lowest coin is removed, the inertia of the other coins make them fall vertically on the table. And when the lowest coin is removed quickly, the inertia of the other coins make them fall vertically on the table. Let's see, we will see this experiment via video. I am using one video which are available in the YouTube. Let's see student this experiment. See here, wait, I will do some clarity in that. I will start from first. See here, at the first they have shown. Now see, one striker hit at the bottom of the coin. See now, and the vertical coins come downside on the table. See once again the experiment. These coins are not fall, they are stand as it is on the table, just one coin removed from the bottom and other coins stay as it is. See now, just now, see here, one coin has removed and other coins fall as it is on the table. I hope you understood it better. This is the figure 9.6. Only the carom coin at the bottom of pile is removed. Just now we have seen in the video. When a fast moving carom coin or striker, when it is removed, when we hit to the pile with the strong hit of a striker, that time one coin removed from the bottom side and other coins makes them fall vertically on the table. Now we will move towards on next page. On this page, activity 9.2 is there. Set a 5 rupee coin on a stiff card covering an empty glass tumbler standing on a table as shown in figure 9.7. In this way, give the card a sharp horizontal flick with a finger. If we do it fast, then the card shoots away, allowing the coin to fall vertically into the glass tumbler due to its inertia. Means when we give a sharp horizontal flick in this way, what will be happen? Then the card shoot away and the coin fall vertically on the glass. The inertia of the coin tries to maintain its state of rest even when the card flows away, and the inertia of the coin tries to maintain the state of rest even the card flows off. Means coin stay as it is. See here. Now we will see this experiment via video. Now the coin drop into the glass. In this way, we have seen the experiment. Now we will move towards next, and which experiment just we have seen, that is when the card is flicked with the finger, the coin placed over it fall in the tumbler. Means the card flown away and the coin will fall on the glass. The coin maintain its rest position even the card flown away. Now next activity 9.3 is there. This activity, place a water filled tumbler on a tray, then hold the tray and turn around as fast as you can. We observe that the water spills white. This experiment again we see via video. Please student wait for some time, we will see that experiment. Just wait.
Newton's first law of inertia states an object at rest stays at rest, and an object in motion will stay in motion at the same speed in the same direction and is acted upon by an unbalanced force. Objects tend to resist changes in their state of motion. This tendency to resist changes in motion is what we know and describe as inertia. This is one of many experiments to prove inertia. I am going to do the coin in the cup demonstration. For this, you will need a glass, an index card, and a few quarters. It works with more than just one quarter. Whilst the coins were on top of the card, they were at rest. The reasons the coin fell vertically and not horizontally is because there was no friction between the card and the coins, but also because there was no horizontal force carrying them that way. Gravity, the outside force, not made them onto the glass. If this experiment with the rays of something had a lot more friction with the coins, then the outcomes would be similar.
I have you understood it better. The experiment. Observe that a groove is provided in a saucer for placing the cup tea. It prevents the cup from toppling over in case of sudden jerks. I will show one experiment, and that experiment is also based on that. See here. I hope you understood it better. Now we will move towards next point, that is 9.3, inertia and mass. All the examples and activities given so far illustrate that there is a resistance offered by an object to change its state of motion. In above examples and activities, we illustrate that there is a resistance offered by an object to change its state of motion. We have seen in place of coin. If it is at rest, it tend to remain at rest. In example, we have seen the coin is remain in its rest state. If it is moving, it tends to keep moving. Otherwise, when it moving, it tends to keep moving. This property of an object is called its inertia. Do all bodies have the same inertia? We know that it is easier to push an empty box than a box full of books. Means if we push to the empty box, it will go forward, but that box is if filled with books, it can't move. Similarly, if we kick a football, it flies away, but if we kick a stone of the same size with the equal force, it hardly moves. Please student, do you this activity. First you kick to the empty box, or you kick to the football, and then you can kick also to the stone. Let's see what will be happen. We may in fact get an injury in our foot while doing so. Please don't do that. Just in joking, I have told you. But similarly, if we kick to a football, it flies away. But when we kick to the stone, that time that stone will not fly away. It stay in the rest position only. And if we kick with your leg to the foot to the stone, what will happen? It will be get injured. Similarly, in activity 9.2, instead of a 5 rupee coin, if we use a 1 rupee coin, we find that a lesser force is required to perform the activity. In place of a 5 rupee coin, if we take 1 rupee coin, that time lesser force is required to perform the activity. A force that is just enough to cause a small car to pick up a large velocity will produce a negligible change in the motion. A force that is just enough to cause a small car to pick up a large velocity will produce a negligible change in the motion of, of a train. This is because in comparison to the car, the train has a much lesser tendency to change its state of motion. You can comparison in between car and a train. Train has a much lesser tendency to change its state of motion. According to, we say that the train has more inertia than the car, and that's why the train has more inertia than the car. Clearly, heavier or more massive objects offer larger inertia. Those who are heavier or more massive objects offer large inertia. Quantitatively, the inertia of an object is measured by its mass. We may thus relate inertia and mass as follows. See here. Inertia is the natural tendency of an object to rest a change in its state of motion or of the rest. But as told, inertia is the natural tendency of an object to resist a change in its state of motion or a rest. Inertia is the natural tendency of object to resist a change in its state or motion or in rest. The mass of an object is a measure of its inertia, and the mass of an object is measure of its inertia. I hope you understood it better. If you have any queries, please comment your queries. We will solve it. And please subscribe my channel and send this video to your friends, neighbor and relative. And show your thumb to the videos. Thank you.